Most students miss questions like these on the SAT and ACT. Today, we're solving 5 of the hardest questions students struggle with. Learn these strategies now so if a similar question appears on test day, you'll know exactly what to do. All right, let's carefully walk through this ACT question step by step. We are given the equation 1/2 times a times b squared plus c equals d, and the goal is simple. We want to rewrite the equation so that b is alone. Right now, c is being added on the left side. To get rid of it, we subtract c from both sides. That leaves us with 1/2 times a times b squared equals d minus c. So now everything except the b term is on the right. Next, we want to remove that 1/2 in front. The easiest way is to multiply both sides by 2. When we multiply both sides by 2, the 1/2 disappears. Now we get a times b squared equals 2 times quantity d minus c. So the fraction is gone and things are cleaner. But we still don't have b alone. Right now, a is multiplied with b squared, so we divide both sides by a. Now we have b squared equals 2 times quantity d minus c divided by a. Now only b squared remains on the left. The variable is still squared. To undo a square, we take the square root. Taking the square root of both sides gives b equals the square root of 2 times quantity d minus c divided by a. And now b is isolated. Looking at the answer choices, this expression matches answer choice G, so the correct answer is G. All right, let's slow this problem down because this type of question confuses a lot of students. We are told h of f of g of a equals 1, and the question is asking, what number is a? So our goal is to find a. When we see h of f of g of a, this means we are plugging numbers into functions one step at a time. Here's the order. First, we put a into g. Then, whatever number comes out goes into f. Then that result goes into h. And the final result equals 1. So the chain looks like this: a to g to f to h to 1. But solving forward is hard. So instead, we go backwards. Because we already know the final answer is 1. So instead of guessing a, we ask, what number went into h to give 1? So we look at the table. We scan down the h column. We ask, where does h give output 1? Looking in the table, we see h of 2 equals 1. That means the input to h had to be 2. So now we know f of g of a equals 2. Now we ask, what number goes into f to give 2? Looking in the f column, we see f of 1 equals 2. So the input to f had to be 1. That means g of a equals 1. Now we ask, what number goes into g to give 1? Looking at the g column, we see g of 5 equals 1. So the number that went into g was 5, and that means a equals 5. So the value of a is 5. Whenever you see stacked functions like this on the ACT or SAT, remember, start from the final output and work backwards through the table. All right, let's read the question first. We are told, given that m is between 1 and 4, n is between 4 and 6, and p is between 8 and 10, what is the greatest possible value of m over n multiplied by 1 over p? So the question is asking, what is the largest possible value of this expression? Before we plug in numbers, we need to remember how fractions behave. A fraction becomes larger when the number on top gets bigger and the number on the bottom gets smaller. So, to make this expression as large as possible, we want the top numbers big and the bottom numbers small. Look at the expression m over n multiplied by 1 over p. Notice m is on top of a fraction. N and p are both in denominators, meaning they are on the bottom. So, to make the result as big as possible, we choose the largest possible value for m and the smallest possible values for n and p. From the problem, m can go up to 4, so we choose m equals 4. N can be as small as 4, so we choose n equals 4. P can be as small as 8, so we choose p equals 8. These choices make the fraction as large as possible. Now plug the values into the expression. 4 over 4 equals 1. So the expression becomes 1 times 1 over 8, and that equals 1 over 8. So the greatest possible value is 1 over 8, which matches answer choice D. This question says, in the standard xy coordinate plane, how many points are both 5 coordinate units from the origin and also 2 coordinate units from the line y equals 0? So we need to find how many points satisfy both conditions at the same time. Let's translate each condition into a picture. The origin is the point 0, 0. Now here's an important idea. If you mark all points that stay the same distance from one point, the shape you get is a circle. So every point that is 5 units away from the origin forms a circle centered at the origin with radius 5. The line y equals 0 is just the x-axis. So what does it mean to be 2 units from the x-axis? It means your vertical distance from the x-axis is 2. So your y value must be either positive 2, meaning 2 units above, or negative 2, meaning 2 units below. So this condition gives us 2 horizontal lines, y equals 2 and y equals negative 2. The question says the point must satisfy both conditions. So we are looking for points that lie on the circle and also on those horizontal lines. In other words, we want the intersection points between the circle and those lines. Now let's count. The line y equals 2 crosses the circle in 2 places, one on the left and one on the right. And the line y equals negative 2 also crosses the circle in 2 places. So we get 2 points on top, 2 points on the bottom. That gives a total of 4 points. So the number of points satisfying both conditions is 4, which corresponds to answer choice J. All right, let's read the problem first. In rectangle A, B, C, D shown, segments BE and CE divide the rectangle into 3 triangles. Given that DE equals 7 centimeters, BE equals 26 centimeters, and CE equals 25 centimeters, what is the length of BC? So our goal is to find the right side of the rectangle, segment BC. Since this is a rectangle, all the corners are right angles. That means we can use right triangle relationships, especially the Pythagorean theorem. We are going to solve this in 2 steps. First, find the width of the rectangle. Then use that result to find the height, which is BC. Look at triangle DEC at the bottom. This triangle is a right triangle. We know DE equals 7, EC equals 25, and we want to find DC. Using the Pythagorean theorem, DC squared plus 7 squared equals 25 squared. So DC squared plus 49 equals 625. Subtract 49 from both sides. DC squared equals 576. Taking the square root gives DC equals 24. So the width of the rectangle is 24. Now we use the top triangle connecting E to B. The horizontal distance across the rectangle is still 24, but vertically, E is 7 units above the bottom. So the total height, which is BC, is h, and the vertical piece from E up to B is h minus 7. Now we use the Pythagorean theorem again. 24 squared plus h minus 7 squared equals 26 squared. Now h minus 7 squared equals 100. Taking square roots gives h minus 7 equals 10. Add 7 to both sides. H equals 17. And h represents the full height of the rectangle, which is segment BC. So the final answer is BC equals 17. And that corresponds to answer choice C. When rectangles contain diagonal segments, look for right triangles and use the Pythagorean theorem step by step. Solve one triangle, then use that result in the next, and that's it.